Hello, my name is Leah Blank, and this is my video for Problem Set 4 for Bio151. This is my diagram, and the topic I've chosen is the release of neurotransmitters from the postsynaptic cell to the presynaptic cell and how that sends a signal. This process is also called chemical transmission. So this process starts with the presynaptic cell that we have right here, and it's going to get an action potential from way up towards the top of it, the dendrites, and it's going to travel all the way down to the bottom where we're at the axon terminal for this neuron. At this neuron, the action potential has reached here, which is a rapid temporary reversal of the electrical charge in a neuron. This causes voltage-gated channels, like this calcium-gated channel, to open up. And because the calcium outside the cell and the calcium inside the cell means that there's a lot more out and a very little in, the opening of the gated channels from the action potential is going to allow the calcium to come into the cell. Because the calcium is coming into the cell, the calcium will tell the interiors different signals. So inside this presynaptic neuron, we have vesicles with red neurotransmitter in them. The calcium, when it comes in, will tell these vesicles to release into the synaptic cleft, which is the space in between the presynaptic neuron and the postsynaptic neuron. So it would look something like this. Now, these neurotransmitters are also ligands, which is important because in the postsynaptic cell, we have these ligand-gated receptors, which are specific to a certain ligand. In a real neuron, there would be a ton of different receptors that would bind to a ton of different types of neurotransmitters. But in this case, I've only drawn ones that are receptive to this red neurotransmitter. Now, when this red neurotransmitter, which is a ligand, binds to the ligand-gated receptors at the edge of this postsynaptic neuron's dendrite, these neurotransmitters are going to either be allowed in or send a signal into this neuron, and from there, it can cause two different reactions. The first reaction is an excitatory postsynaptic potential. An excitatory one, like the name suggests, makes the cell more likely to cause an action potential. So this means that this postsynaptic cell is getting depolarized and becoming more positive. So it's closer to creating an action potential than it was before. The other reaction that it can have when it comes into the cell is inhibitory postsynaptic potential. This causes hyperpolarization, which means that it becomes way more negative than it was initially, and it's less likely to flip charge and cause an action potential. This is my video on chemical transmission. Thank you for watching. I hope you have a great day.